We have seen that the thermodynamics properties of a system define its state. So the questions which come to mind are, how many properties are needed to define the state? And the second question which immediately comes to mind is, which ones? Actually, thermodynamics tells us something about these, but does not really give a definitive answer. It does not say 4 properties, or it does not say pressure, volume, temperature. However, there are in thermodynamics what are known as state postulates, which tell us something about the number of properties, not necessarily about which ones. Which ones is to a very large extent our choice, our convenience. Now, since we have used the word postulates, let us spend some time on these words. Postulates, premises, assumptions and laws. Not all of these are related. There are differences, but we will be coming across these words, laws, assumptions, premises and postulates, reasonably often in our study of thermodynamics. Actually, there is hardly any significant difference between postulates, premises and laws, particularly between postulates and laws. These are our understanding of the way nature behaves. We observe nature. All science does is that it observes nature, and by pattern matching, generalization, repeated observation, so called inductive logic, comes to a conclusion that this is the way nature behaves. And this behavior, when written down formally, becomes a postulate or a law, sometimes called a premise. But the main name for these things is postulates or laws. In thermodynamics, there will be a number of postulates or laws that we will come about. However, there are only a few of those, particularly 3. The 0th law, the 1st law and the 2nd law have been given formally the status of a law. The other things we call a postulate. For example, the state postulate. A premise or an assumption, it's somewhat different. Now, this is something which we make to simplify the study, sometimes to restrict ourselves, so we do not have to worry about too many things too soon. The first postulate, let me call it state postulate 1, is that the state of any thermodynamic system can be defined using primitive properties only. This means that although we talk about quantities like thermal energy, temperature, entropy, it is not necessary for us to define the state of a system using any of these. State of a system can always be defined using primitive properties like mass, volume, pressure, velocity, location and things like that. Okay. Now, this is something which is a postulate, so we do not have a derivation for this, but the way we have observed nature and thermodynamic systems to behave, it has been found to be true. No contradiction has occurred. So, let us call this state postulate 1. For simplifying our study of thermodynamics and to restrict ourselves to the classical domain of thermodynamics, we will be making the following assumptions. These are our premises. We will be making many of these, a few which immediately are of interest to us, that any system is part of a continuum. So, no discrete effects, no quantization. Second assumption which we will make is that there are no scale effects. That means whatever is true for a small system will be true for a smaller system, will be true for a larger system, and will be true for a still larger system. The third assumption which we will make for this course is that there are no quantum effects. That means any property varies continuously. And the fourth assumption we will make is that there are no relativistic effects. These four assumptions or premises will simplify things very significantly for us, and henceforth we will not mention these assumptions again, but we will use them as and when required.